Hello everyone and very good morning. I hope you all are good, doing well, practicing more number of questions. So that is all we require, right? Exam date is quite near. So in this period, what we require is more amount of practice, I would say. Okay. So I hope you people are practicing questions from all the chapters and from all the subjects. Today in the class, we are going to revise EMI and AC. So first, I will take you through concepts, basic formulas that is required. And after that, quickly, really today we will be doing more number of questions. So let's quickly go through it. First thing is magnetic flux, how we define it. So magnetic flux is defined as what? Just like you define electric flux, that is B dot A. Dot product of magnetic field and area vector. Area vector, how we define the direction of area, that is normal to the area and outward normal we take. Okay? So this is magnetic flux. Then we have learned Faraday's law of induction, and he gave us the idea of what happens when flux changes through certain structures, right? So when flux changes, EMF is generated, and EMF value is given as minus. If you this is written as minus d phi by dt. Okay, so EMF generated is equal to negative of rate of change of flux. Negative sign has to do with the direction of EMF getting generated, which is given by Lenge's law. So सबसे पहले आप ये देख लो कि EMF generation का magnitude we write as what? d phi by dt, which is rate of change of flux. So if flux has changed from phi to phi 1 to phi 2, then phi 2 minus phi 1 divided by delta t. Also from here we get one question that is related to if flux is changing by certain amount, then what is the amount of charge that has flown? Because देखो यहाँ पे if EMF is getting generated, what does it mean? If the circuit is closed, current will flow. Done है? And if current is flowing, it means charge is flowing. So यहाँ से एक और question आता है इस formula से EMF is equal to delta phi by delta t से you may get asked what is the amount of charge flowing. So EMF को आप क्या लिखते हो? Current electricity में चले जाओ. Current is written as what? It is written as potential difference, that is EMF divided by R. ठीक है? EMF और potential difference में difference है that you already know, but here E I am writing as the potential difference that you are getting across the resistance R. ठीक है? So I can be written as what? Delta Q by delta T. ठीक है? So E can be written as what? E can be written as delta Q divided by delta T into R equal to delta phi by delta T. Delta T को आप कट कर दो. So amount of charge that will flow because of flux changing by delta phi will be equal to delta phi by R. So this formula is a very important formula. Questions आ सकता है and then that may be called a good question. So this is important and definitely this formula is important. Okay, so two things from here. After that, Lenge's law, it talks about the sense of EMF or direction of EMF getting generated. So Lenge said that EMF generated will oppose the cause. Okay? So because of EMF generated, whatever current is getting generated, that current will basically oppose the reason because of which it got generated. जैसे यहाँ पे आप देखो, this north and south pole having magnet is moving towards the coil. South pole is approaching. So because of south pole approaching, this type of flux will increase through the coil. This inward flux will increase through the coil. So reason here is what? Reason is that inward flux is reason क्या है? Inward flux increasing. Done it? And because of this flux increasing, EMF will get generated. And because of that EMF, there will be current in the coil. And sense of current will be in such a way that it will oppose the reason. Yani ki it should create outward flux. That generated current. So generated current will outward flux ka matlab, this is inward. Then generated flux should look like this. And this is when possible. This is only possible if current is flowing in anti-clockwise sense. That is, current is flowing in this sense. ठीक है. So this way, by using Lenz's law, we can determine what will be the direction of current because of EMF getting induced. Or in short, you can also tell which end. I mean, that we will discuss later. But यहाँ पे current का sense you can discover. After that, we have learned of one more thing, that is motional EMF. What is motional EMF? Whenever there is a rod moving in magnetic field, then we expect motional EMF there. But motional EMF आएगा कब? So there are two cases. First thing is rod plane. Rod का जो plane है should be perpendicular, or you can write this like something like this. Magnetic field जो है ना यहाँ पे is in this region, जो magnetic field है should be perpendicular to the plane of rod. So magnetic field should be perpendicular to the plane of rod. First thing. So if there is any other case like magnetic field is directed in this sense and there is rod kept in the same plane, and if this rod is moving, there won't be EMF getting generated. Why? Because magnetic field is not perpendicular to the plane of rod. It is in the plane of rod. So no EMF. Reason I cannot explain as of now because that's the thing of discussion we did already in the classes, right? So in that case, अभी तुम्हें ये पता करना है in which cases or scenarios EMF will get generated. First requirement is B should be perpendicular to the plane of rod. Second, velocity should be perpendicular to the length of rod. ठीक है? Then only EMF will get generated. So here if you see, I have given velocity to the rod, which is making an angle theta with the length. So this velocity will have two components. Done it. One perpendicular to the rod, that is V sine theta, and another is your parallel to the rod, that is V cos theta. So because of V cos theta, no EMF getting generated. Because of V sine theta, EMF will get generated. और EMF का formula आप क्या लिखते हो? BVL, where V is perpendicular to the length. So here VV sine theta into L. So this is EMF getting generated. Now, next important thing is that if EMF is getting generated, which end of the rod will be having positive potential and which one negative? Because if EMF is getting generated, such sort of thing will arise. Either A point will be positive or B point will be positive. Done it. So how we will determine that? उसको determine करने का simple तरीका है. Just go with the formula F equal to QV cross B. Because when conducting rod is moving in a magnetic field, whatever free charge is inside the rod, that is also moving in the magnetic field. Done it? वो भी move कर रहा है साथ साथ. So when charge is moving in a magnetic field, then force will act, and because of this force, charge will get separated. So one will accumulate at the end A, another will accumulate on the end B. So let's calculate in this case force acting on positive charge. Velocity का direction क्या है? Velocity direction is I cap, right? And what is the direction of magnetic field? Minus K cap. I cross minus K cap क्या होगा? अगर आप भूल जाते हो तो simple ये चीज याद रखो. When you go like this, you write positive. I cross J is K cross I is J. But if you calculate I cross K in this direction, then I cross K is minus J. And here I cross minus K, that will be plus J. So here positive charge will go towards plus J, that is towards A, and negative charge will remain here. That is EMF getting generated will be in such a way that A will become positive, B negative. So battery का sense कुछ ऐसा ही होगा. Done? So this is how we can do things. Next important thing was that you all must have seen this thing in your NCERT textbook. So if there is this railroad arrangement sort of thing, there is this conducting system, and this conducting system is kept in an inward magnetic field. And then what we are doing, we are keeping a moving rod on it. Then so this rod is moving in this sense. Now what other things can happen over here? That thing we are now going to explore. So what can happen? Since this rod is a moving rod, magnetic field is also perpendicular to the plane of rod, EMF will get generated. Okay? So what will be the value of EMF? Value तुम directly लिखोगे BVL. No problem. Now what will be the direction of this EMF? So this rod is like this. It is moving in this direction. मैग्नेटिक फील्ड इज इनवर्ड, डायरेक्शन के लिए फोर्स का डायरेक्शन देख लो पॉजिटिव चार्ज पे, सो वेलोसिटी इज इन माइनस आई कैप डायरेक्शन, मैग्नेटिक फील्ड इज माइनस के कैप डायरेक्शन, and you already know I cross k is what, minus j. So for this rod, positive charge will go to the bottom, negative charge to the top. So अगर आप इस रॉड के लिए EMF बनाओ तो क्या होगा, इस रॉड का up will be negative and down will be positive. And if this rod is kept in such a way that it is forming a closed circuit, जैसे here it is forming a closed circuit, so current will flow. And current direction will be in what sense here? Current direction will be in this sense. ठीक है, current direction will be in this sense. Sorry, मैं opposite लिख रही हूँ. करंट ऐसा नहीं होगा ना, क्योंकि बॉटम पॉजिटिव एंड है. सो अगर मैं किसी भी इंस्टेंट पे, सपोज कर लो किसी इंस्टेंट पे रॉड यहाँ है, सो जब किसी इंस्टेंट पे रॉड यहाँ है, ये एंड पॉजिटिव है, ये नेगेटिव है. ठीक है, सो करंट विल फ्लो लाइक दिस, सो करंट विल गो लाइक दिस. ठीक है, सो करंट इन द सर्किट आप क्या लिखोगे, ईएमएफ गेटिंग जनरेटेड डिवाइडेड बाय रेजिस्टेंस ऑफ द सर्किट, whatever is given, this is current. Now the moment current will arise in the circuit, what will happen? Now there is current flowing through the rod, and now this is a current carrying rod in magnetic field, and then force will act on the rod. Force acting on the rod will be what, IL cross B. अब आप देखो what is the direction of this force. If you talk about direction of this force, then current flowing in the rod is in which direction? Is in minus j cap direction. Magnetic field is in which direction? Minus k cap. So यहाँ पे minus j cap cross minus k cap. So j cross k क्या होता है? J cross k is I. So on this rod, force will act in the I cap direction, and velocity was towards the opposite sense, right? So because of this magnetic force acting, this rod will slow down, है ना? क्योंकि initially rod was moving with a velocity v. Now you're applying a force F on it. What will happen? Velocity will decrease. So if you want to make it, or if you want this rod to keep on moving with velocity v, you need to apply external force such that this external force is equal to the magnetic force acting. Done it? So we need to do external work in that case. And hence we need to apply power so that this rod will keep on moving with velocity v. Done it? So question में पूछता है what will be the power applied? तो power applied क्या होगा? Force into velocity. Simple. How much force you need to apply? ILB. And with what velocity you want it to keep on moving? V. So ILB into V. अब आप values put कर दो. I is how much? BVL by R. And this is L. This is B into V. So this is B square L square. Yes, v square भी आ रहा है ना? Yes, by R. This is the power. ठीक है, this is the calculation. This is all that can come from here. चलो अब हम चलते हैं self inductance पे. If you talk about self inductance, there is a inductor in the circuit. Then how we write the, I mean there is back EMF sort of thing getting generated over here. उसको हम कैसे लिखते हैं? Back EMF here is written as minus L di by dt, where L is called what? Self inductance of the inductor. L का फॉर्मूला हम क्या लिखते हैं? L का फॉर्मूला हम लिखते हैं म्यू नॉट n स्क्वायर AL. ठीक है, दिस फॉर्मूला इज इंपॉर्टेंट, यहाँ से डायरेक्ट क्वेश्चन आया है. N is what? Number of turns per unit length of this length for L लिखो यहाँ पे, of this inductor. ठीक है, एंड व्हाट इज ए? एरिया ऑफ क्रॉस सेक्शन, यानी कि वन लूप का एरिया अगर ये है तो दिस एरिया, एंड एल इज व्हाट? लेंथ ऑफ द इंडक्टर. सो म्यू नॉट एन स्क्वायर AL. सेल्फ इंडक्टेंस का फॉर्मूला म्यू नॉट एन स्क्वायर AL. Always remember. And how we can write EMF getting generated or back EMF across the inductor? Minus L di by dt. ठीक है, क्योंकि हम फ्लक्स को कैसे लिखते हैं? फ्लक्स थ्रू इंडक्टर इज रिटन एज LI. If I current is flowing through it, then flux is written as Li. और EMF हम कैसे लिखते हैं? Minus d phi by dt, and that is why minus L di by dt. So you should remember two formulas. How we write flux through the inductor? So if current flowing is I through the inductor, then I into self inductance. सेल्फ इंडक्टेंस का एसआई यूनिट क्या होता है, हेनरी होता है, एंड इट्स फॉर्मूला फॉर इंडक्टर इज दिस, ठीक है. Similarly, if you talk about mutual inductance, then I have taken two coil here, coil 1 and coil 2. So flux through coil 2 will be directly proportional to whatever current is flowing through coil 1, क्योंकि coil 1 के through current flow कर रहा है, and because of this there is flux getting linked with coil 2, ठीक है. So flux through coil 2 will be directly proportional to I1, और phi 2 को हम क्या लिखते हैं, M21 I1, mutual inductance of 2 with respect to 1 into I1. Similarly, phi 1 अगर आप निकालो, यानी कि अगर सेकेंड कॉइल के थ्रू करंट फ्लो करवाओ and try to see what is the flux getting linked with 1, then phi 1 will be directly proportional to I2, and in that case phi 1 you will write as mutual inductance of 1 with respect to 2 into I2. Similarly, you can define EMF, and experimentally it is seen M12 is equal to M21, ठीक है. So even if you know one, you know another, ठीक है. EMF getting generated here you can write as minus M di by dt, जनरल मैंने लिख दिया, ठीक है. Mutual inductance का formula we have calculated for two sets of coil which are superimposed on each other. So formula is this. इसको याद कैसे करना है, सेल्फ इंडक्टेंस के लिए मैंने बताया म्यू नॉट एन स्क्वायर AL, यहीं से याद रखो. n को यहाँ पे दो पार्ट में ब्रेक कर दो बिकॉज वी आर हैविंग टू कॉइल्स, सो n1 into n2. एरिया कौन सा होगा, ऑलवेज टेक द एरिया ऑफ स्मॉलर वन. सो हियर दिस एरिया दैट इज पाई r1 का स्क्वायर, बिगर वन का रेडियस मैंने r2 लिया, ठीक है. एंड L इज व्हाट, L इज द लेंथ ऑफ inductor here. So there are two inductors here, that is why we are defining mutual inductance, and this is the formula, ठीक है. उसके बाद mutual inductance self inductance से कैसे related है, जैसे there were two coils, they were superimposed on each other. So there are two coils, each coil will have their self inductance, let's say L1 L2. So their mutual inductance is related as k root under L1 L2. If nothing is given in the question, k को आप 1 लेकर चलोगे, ठीक है. We join inductors in series and parallel. When inductors are in series, join them like resistors like this. When inductors are in parallel, join them like you do with the resistors like this, ठीक है. Now AC सर्किट में देखो, मैं तुम लोगों को सिंपल बताऊं, AC सर्किट बहुत इजीली सॉल्व हो सकता है. सबसे पहले I have taken LCR सर्किट, ठीक है, because if you know LCR circuit, you can solve any circuit. Whatever circuit is given, how you will calculate resistance of the circuit, that is also called impedance. In case of what, in case of AC circuit, impedance. So how we calculate impedance? So impedance is written as, indicated by letter Z, R square plus XC minus XL का square. This is the impedance of circuit. XC is equal to what, 1 by omega C. XL is equal to what, omega L. Omega is what, angular frequency of the voltage getting supplied. In case frequency is given in the unit hertz, you need to calculate omega, and omega is related with frequency like omega equal to 2 pi f. So this is how you can calculate impedance. If you know net resistance of the circuit, you can calculate current, right? So if voltage applied is this, we already know the value of Z now. So how we will calculate current? Current is basically, अगर मैं maximum current की बात करूं, तो maximum voltage, that is V0 divided by impedance, that is Z. And if I talk about current at any time t, then that is written as V0 by G Z sine omega t plus phi. So I am saying voltage has a phase. Phase is what? Whatever is in the angle. So sine के बाद यहाँ omega t है, so its phase is omega t. And here sine के बाद angle is omega t plus phi, so phase is omega t plus phi. So we can clearly see there is phase difference of phi between voltage and current, right? So if we actually need to write I, we also need to write the value of phi, because we already know the value of Z, V0 by Z, I0 is clear. Sine omega t is already given, omega is already given, phi we need to calculate. One more thing I want to tell you, how you will compare phase of two things if that is given in the question. Always go with same trigonometric function. जैसे यहाँ पे voltage का phase मैंने बोला omega t, and current का phase मैंने बोला omega t plus phi. I said this simply because here there is sine function and here also there is sine function. So I simply compared their angles. If one is sine function, and let's say I am writing current as I naught cos omega t plus phi. Then can I say that current has a phase difference between voltage and current is phi? No, because here there is cos function, here there is sine function. First, we need to bring them in the same function. So either convert sine into cos. So यहाँ पे either आप लिख लो plus pi by 2 or something like that. Then it will get converted into sine. So when trigonometric function is same, then only compare the phases. ठीक है. So let's calculate phi. Phi निकालना बहुत सारे क्वेश्चन में आएगा. So please remember, just remember a triangle. ऐसे एक राइट एंगल ट्रायंगल बना लो. लेट्स से दिस एंगल इज phi. बॉटम को रेजिस्टेंस ले लो, रजिस्टर का वैल्यू, एंड परपेंडिकुलर को xc माइनस xl ले लो. दिस विल बिकम व्हाट? दिस विल बिकम r स्क्वायर प्लस xc माइनस xl का स्क्वायर. सो दिस इज नथिंग बट इम्पिडेंस. Now you can calculate tan phi, cos phi. I mean, you can calculate phi. So this is how we calculate phi. Now there is a thing, RMS current, RMS voltage. So if current or voltage is as simple as single function of sine like this, or voltage is like sine omega t plus phi dash, something like this, then RMS is written as I naught by root 2, or VRMS is written as V naught by root 2. सिंपल केस में. बट इफ कॉम्प्लेक्स थिंग्स आर गिवन, यू जस्ट कैलकुलेट इट. जैसे अगर आई का वैल्यू तुम्हें दिया है ए साइन ओमेगा टी प्लस बी कॉस ओमेगा टी, एंड यू आर आस्क्ड टू कैलकुलेट द IRMS, व्हाट यू विल डू? फर्स्ट डू द स्क्वायर. सो पहले मैं इसको स्क्वायर कर दूंगी. आई विल गेट ए स्क्वायर साइन स्क्वायर ओमेगा टी प्लस बी स्क्वायर कॉस स्क्वायर ओमेगा टी प्लस 2AB साइन ओमेगा टी कॉस ओमेगा टी, लाइक दिस. ठीक है, स्क्वायर कर दिया. उसके बाद मीन लो. मीन मीन्स एवरेज. सो टेक द एवरेज ऑफ ईच इंडिविजुअल टर्म्स. So we are having one term is this, another term is this, third term is this. You already know average of sine square is half, right? So यहाँ पे simply लिखो a square by 2. यहाँ पे b square by 2. Now what is this term? AB sine 2 omega t. And average of sine is always 0. So this will become 0. ठीक है. इसका अगर हमने एवरेज लिया, वी विल गेट समथिंग लाइक दिस विल बिकम 0. सो ओवरऑल कितना हुआ बताओ? ए स्क्वायर प्लस बी स्क्वायर बाय 2. सो यू डिड स्क्वायर फर्स्ट, देन यू took the mean, then now you are going to take the root. So take the root of it. That is your answer. So this is how we can do it. ठीक है. Now how we calculate power? Power is written as VRMS IRMS cos phi. And cos phi you can write from here. Cos phi will be equal to how much? R by Z. This cos phi is called power factor. This is called what? Power factor. Done it? So whatever circuit is given, अगर तुम्हारे circuit में सिर्फ C है, suppose कर लो, R और L नहीं है, so simply यहाँ पे XL को 0 कर दोगे, R भी 0 हो जाएगा, then you will see what is cos phi. Done it? So if you remember overall things for LCR circuit, you can do it for any circuit. कोई भी सर्किट हो, एल नहीं है तो एल को 0 कर दो, आर और सी सिर्फ है तो सिर्फ उसको रखो, सी और एल भी नहीं है तो सिर्फ आर को रखो. अकॉर्डिंगली यू कैन डू, एनी कॉम्बिनेशन इज पॉसिबल. देयर इज वन इंपॉर्टेंट थिंग दैट इज कॉल्ड वॉटलेस करंट. व्हाट इज दिस? ठीक है, बहुत इंपॉर्टेंट है. वॉटलेस करंट ये होता है, जैसे हियर आई टोल्ड यू थिंग्स, वोल्टेज इज वी नॉट साइन ओमेगा टी. करंट को हमने क्या लिखा था? आई नॉट साइन omega t plus phi. What is the phase difference between current and voltage? Phi. So same thing I have written here. I have written like this. V I have written like this. Angle difference between these two is of phi. So this is the phase difference. Okay. Now what is the whatless current? So component of current which is perpendicular to the voltage, that is whatless. So here I sin phi जो है ना तुम्हारा, this is whatless current. Whatless current का मतलब the current value which won't contribute to the power generation. ठीक है. And here another component is I cos phi. Because of this power will get generated. इसलिए हमने यहाँ पे देखो power में cos phi का term आया है. Done है. Sin phi is not there because that's a whatless current that is not contributing in the power. Remember it. ठीक है. Now AC generator में I cannot explain the mechanism, but I can tell you EMF getting generated is this, where n is the number of turns. जैसे वहां पे हमारे पास एक soft core होता था, electromagnet on which there are this thing, ठीक है, coils are there. So there are different number of turns. let's say n number of turns are there. Each turn has area A. Magnetic field present is B. And let's say this whole system is rotating with angular velocity omega. Then EMF getting generated is NABW omega sine omega t. Maximum value of EMF, that is in Emax, is equal to how much? NAB omega. Direct question from here has came several times. Now AC transformer. Transformer में formula that you need to remember is this. There can be two sort of transformer, step up, step down. In a step up, basically you're increasing voltage value. In a step down, you're decreasing it. Whatever is the case, these three things are true there. और ये सारी चीज कहाँ से आया है? I mean, there is no power loss case happening. So basically in transformer, there are two coils, primary coil, secondary coil. So let's say this is the primary coil. Let's say this is the secondary coil. In primary coil, we feed the voltage. So we are giving it voltage, let's say VP. Then there will be current getting generated here, let's say IP. So power we are feeding is VP into IP. And if there is no power loss, complete linkage of flux is happening, then same power will get transferred to the secondary coil. तुमने transformer पढ़ा होगा, primary के ऊपर ही secondary को हम डाल देते हैं, so that linkage is strong, right? So if you write here like this, you will be writing power across secondary, voltage getting generated across secondary into current getting generated. And if there is no power loss, these two are equal. So VP by VS, VP by VS will be equal to IS by IP. And this again is coming. Again, we cannot go into detail, but these are the formula. अगर भूल जाओ तो ये याद रखना, ठीक है? And VP by VS is NP by NS. Number of turns से वो directly proportional होते हैं voltage. Because more number of voltages, more amount of voltage will get generated when more number of turns are there. Because more number of turn, more flux linkage, and EMF getting generated is minus d phi by dt. More flux, more EMF, right? So इसलिए VP is directly proportional to NP. In short, मैं ऐसे समझा सकती हूँ. But this is the thing. Remember it. Now we will do questions. ठीक है? अब तुम लोग अपनी energy high रखो and please get on to questions. I need to finish all question is 30 minutes. ठीक है? So I hope you people will be together. Question में कुछ नहीं है, only formula putting, getting answer type maximum. चलो, take your time, do it. ठीक है? Okay, I got one correct answer. Very good. Punit, without inductance, कभी कभी इंडक्टर के पास भी रेजिस्टेंस होता है. जैसे ये इंडक्टर है ना, इसका सेल्फ इंडक्टेंस, सपोज इंडक्टेंस इज गिवन एज L. Since it is made of some material, it also has some resistance. But that you will only include if that is given in the question. But what's your question? I'm not getting your question directly. Can you explain more? Okay, 3 correct answers. Very good. Now I'm going to end the poll. I've given you more than 2 minutes here. Yes, Ruti. Puneet, if you have not got your answer, you can explain your question again. Okay? So let us consider two solenoid we are having, solenoid A and solenoid B. What is the case? Uh, both have same area of cross section. So area of cross section for both is same. What else? Mu is also same. So let's say mu is also same. Length of A is twice that of B. So let's say length of B is L, then length of A will become 2L. And the number of turns per unit length in A is half that of B. So let's say it is N here. So here it will be N by 2. Now you have to calculate LA by LB. So LA by LB will be equal to what? Mu naught N square AL, put the formula. So for A, it is mu N square by 4 into A into L, 12 divided by mu naught N square AL, mu. Okay? When you will do this, you will get what? 1:2. That's the answer, right? Simply formula. चलो जल्दी से बताओ इसमें क्या होगा. This is also coming straight from the formula. Value of maximum EMF getting generated, right? Just now I have told you. क्या था formula? EMF NAB omega. Maximum EMF. As a function of time, it was sin omega t. Yes. तुम लोग ओमेगा नहीं लिख पा रहे हो क्या? क्या हो रहा है? प्रॉब्लम क्या हो रही है बताओ. I'm I will go. I am taking the screenshot. I will recheck. Okay. We'll let you know. Okay. Nobody answered. I'm ending the poll now. क्या हो गया सभी को? Formula लिखो यार. Omega क्या दिया हुआ है? 1 revolution per second. I have always told you write omega in the unit of radian per second. So 1 revolution per second. 1 revolution means how many radians? 2 pi. So omega is 2 pi radian per second. This is the value of omega, right? So EMF का value आप put करो 100 into 1 into B 5 by 100 into omega, that is 2 pi. So this is how much? 10 pi. That is equal to how much? 31.4 volt. Correct answer is D. चलो जल्दी से बताओ. These all questions are from 24, 23 and 22. ठीक है. Omega always write in radian per second and you should know how to convert it. ठीक है. Phi is given, you have to calculate EMF induced at time t equal to 5 seconds. Okay, I got one correct answer. Others, please, everyone come forward. 3 correct answers. Very good. That's great. Yes, Shruti. Very good. Chalo, now I will end the poll. Okay. So what is the question? Phi is given. EMF you have to calculate. So EMF is written as what? Minus d phi by dt. If you have so t square plus 2t plus 5. Okay. So this will become how much? 2t cube. 3 into 2t square plus this is how much? 8t plus 2. I hope you know how to calculate, how to do differentiation. Put the value of t equal to 5. So this will become 25 into 6 plus 8 into 5 plus 2. So this is 150 plus 40 plus 2. So this is equal to how much? 192. So correct answer is 8. Now do this. I will just give 30 seconds for this question. Because actually you don't need to solve it. You just need to know it. Yes. 1 correct answer. Come on, everybody. 3 correct answers. Others, please. Okay, I'm ending the poll now. What is the thing here? Yes. Shruti, Punit, yes. Correct. So we already know electric flux के लिए formula closed surface का क्या है? This is equal to Q enclosed by epsilon naught. And for magnetic flux through the closed surface, it is always 0. Why? Because magnetic monopole doesn't exist. If you are keeping certain magnetic charge inside, it means it has both positive and negative magnetic charge. That is both north and south pole. And that is why magnetic flux Q enclosed is becoming 0. So correct answer will be D. Now do this. This came in EMS long back when EMS and NEET were separate exam. Separate, yes. So it's a bit old question, but it came again, I guess, in NEET. Yes, Sasank, very good. Shruti, that is previous answer. Okay, okay. Yes, Sasank, great. Punit, yes, correct. है. Shreya, Reshmi, Ranju, Raju, Navyasri, Meenu, Deepu, Divya, Shreya, yes, very good. Chalo, ठीक है. Now I'm closing the poll. And okay, I didn't launch the poll actually. Sorry. So here what the question is, two conducting circular loop of radius R1 and R2 such that R1 is greater than R2. Okay? The mutual inductance M between them will be directly proportional to what? Whenever such questions come, it may be circular, ये circular loop के लिए, maybe you may be asked, it can be asked for, what is that? I mean, square loop or something. Concept is what? अभी अभी मैंने बताया mutual inductance of coil 1 with respect to 2 is always equal to M21. So whichever is easy to calculate, go with that. And if you see here carefully, let's say in this coil current I1 is flowing and in this coil current I2 is flowing. Done it? Then calculating flux through coil 2, because of, I'm calling this as a coil 2, because of current flowing in coil 1 is more easier. Why? क्योंकि देखो coil 1 के coil 2 की अगर बात करो, it has current flowing I2 through it, and if you have to calculate magnetic flux through the bigger coil, then there is a problem, क्योंकि how you will calculate magnetic field at this point, at this point, at this point, because at all these points magnetic field is different, right? So magnetic flux के लिए simple B into A हम नहीं कर सकते, B is a variable there. But if we calculate flux through the smaller coil because of larger one, then there is one advantage, and that advantage is then if R1 here is very much greater than R2, then only that advantage we can take. If R1 is far, far greater than R2, then you can say that whatever magnetic field is at the center because of coil 1, which is equal to mu naught I1 by 2R1, right? This is the magnetic field at center because of coil 1. So if R1 is far, far greater than R2, we can assume that magnetic field at center is same as at this point, at this point, at this, at this, at this, and we can say throughout. So magnetic flux through coil 2 can be approximated to be equal to magnetic field at center because of coil 1 into area of this coil. So area of this coil 2. Okay? This is this, and magnetic flux is written as what? It is written as M into I, and I here you will write as I1. ठीक है? So हमें निकालना क्या था? M between them will be directly proportional to what? तो A2 का एरिया कितना होगा? A2 का रेडियस कितना है? R2 है. So A2 will be pi R2 का square, and this is mu naught divided by 2R1, and this is M. So M is directly proportional to R2 का square by R1. So correct answer is going to be D. So this is how you can calculate. चलो, now let's do this question fast. चलो तुम लोग थोड़ा स्पीड अप करो. क्वेश्चन सिंपल है ये. सिंपली यू हैव टू पुट इन द फॉर्मूला. सो जल्दी से करके बताओ क्या आ रहा है. Yes? Nobody? You just need to put in the formula. Please do it. Okay. This is wrong. Calculate the direction properly. Flux को क्या लिखते हो? B dot A लिखते हो. ठीक है? And here plane of loop is perpendicular to the direction of magnetic field. Plane is अगर suppose कर लो this loop is in XY plane. If loop is in XY plane, magnetic field is along minus K cap or J cap, minus K cap or plus K cap direction. Let's say it is in K cap direction. Question is like this, right? So area vector will be what? Perpendicular to the XY plane. That is along K cap or minus K cap. So angle between B and A is 0 degree, right? So BA cos 0 you will be writing. Or B का value जो भी है put करो, you will get the answer. Yes, Punit. Priya, yes. श्रुति, नीड टू रीचेक है ना, तुमने एंगल में शायद गलती किया है. सो मैग्नेटिक फील्ड का वैल्यू 0.5 रखो. दिस इज इनटू 1. सो 0.5 वेबर. वेबर इज द यूनिट ऑफ व्हाट? यस राजू, वेरी गुड. चलो आगे बढ़ते. नाउ वी विल डू क्वेश्चन फ्रॉम एसी. सो दिस इज द सिंपलेस्ट क्वेश्चन. डू इट. सारे क्वेश्चन बहुत इजी हैं. यू विल बी एबल टू डू इट. Yes, poll is there. You can vote now. Okay, Raju. Yes, that is correct. Very good. Okay, 4 answers, 3 correct so far. ठीक है, चलो अब मैं करती हूँ. इन द सर्किट shown below, inductance L is connected to AC source. Current is given as this. Voltage will be वो. So you must have seen this diagram. मैंने ऐसा डायग्राम बनाया था ना. I wrote here R. I wrote here XC minus XL. I wrote here Z. Right? So similarly, if you will see the thing, यहाँ Z होता है. This is your XL and this is your XC. That is why I wrote XC minus XL. So Z, sorry, this is R. Done it. If this is the line of voltage, then current for the case of inductor, I mean, it will be what? रुको, डायग्राम मुश्किल जा रहा है. No. Okay, give me some time. Let me erase everything. चलो मैं डायग्राम से ना जाकर तुम्हें सिंपल बताती हूँ. What happens through the inductor? Through inductor, current lags voltage, right? करंट तुम्हारा क्या होता है? वोल्टेज से पीछे होता है. So if this is the line of voltage, then this will be the line of current. Current is behind voltage by an angle of 90 degree. So if phase of current is omega t, phase of voltage will be what? Omega t minus pi by 2. So this is the line of omega t. Voltage will be what? Omega t, because when we go in this direction, we write angle as negative. So here, if you will reach from omega t, you are subtracting 90 from omega t. Then, because if this line is omega t, if you will go here, it means minus 90 you have come down. So omega t minus 90. Then that is the phase of what? Okay, मैं opposite बोल रही हूँ ना, बार बार यही गलती कर रही हूँ. सॉरी, करंट है आई नॉट साइन ओमेगा टी ना, मैंने ऑपोजिट बना दिया यार, क्या कर रही हूँ. सॉरी. एक्चुअली समझा मैं सही रही थी, कॉन्सेप्ट वाइज आई वाज करेक्ट, बट डायग्राम गलत बना दिया था. सो इफ दिस इज द लाइन ऑफ करंट ओमेगा टी, ओके, then voltage drop will be, I mean, current through inductor lags voltage by pi by 2. Let's not draw it because पता नहीं मैं गलती कर रही हूँ. So I won't draw it now. Simple voltage को आप लिख दो. So voltage will be what? If current lags voltage by pi by 2, means voltage leads current by pi by 2. So simply V को क्या लिखोगे आप? V naught sin omega t plus pi by 2. Why plus I'm writing here? Because current lags voltage by pi by 2. So current का omega t phase है, voltage का omega t plus pi by 2 है. That is, it is ahead of current. That is, current is behind. Simple है. So if you write voltage, voltage को आप क्या लिखते हो? I into XL. राइट. एक्सएल इज व्हाट? ओमेगा एल इनटू आई को आप क्या लिखोगे? आई को आई लिखो. एंड दिस विल हैव अ फेज ऑफ हाउ मच? दिस वोल्टेज विल हैव अ फेज ऑफ साइन ओमेगा टी प्लस पाई बाई 2. यानी कि ओमेगा एल आई नॉट what? Cos omega t. This is how you can write it. Sorry, I really complicated it. So voltage is basically magnitude. यहाँ पे क्या लिख सकते थे? XL into I naught, maximum voltage का value. So I naught into omega L. Now what will be the voltage as a function of time t? So voltage will be ahead of current by pi by 2. So यहाँ पे साइन लगाओगे और एंगल को क्या कर दोगे? ओमेगा टी से पाई बाई 2 आगे. So omega t plus pi by 2, that is becoming cos omega t. ठीक है? Sorry. Do this now. I ate the time actually. चलो जल्दी करते हैं इसको. स्टेप अप ट्रांसफॉर्मर है and main supply 220 volt is given, and this is to operate at 11,000 volt 88 watt. Current in the secondary circuit is getting asked. Let's do it. Yes, any answer? Yes, Raju. Okay. Maybe there is calculation mistake. Shruti, yes. Raju, you recheck your calculation. Simple है देखो. You have to step up the voltage. Initially it is 220 volt. You have to increase it to 11,000. And then we are asked current in the secondary circuit. So power को conserve कर दो आप. Power, Puneet, no. Simple आप power को conserve करो. So what is the what is the voltage in the secondary? 11,000. What is the current? Let's say I. So power is this. And power is, overall power is given 88 watt. So this must be, yani ki here the power is 88 watt. Here also it should be 88 watt. Done it? So 11,000 into I will be equal to 88. So I is going to be equal to how much? 8 by 1000. That is 8 milliampere. So you just needed to do power thing. मैंने बोला था ना फॉर्मूला कहाँ से आया था. So power conservation. यहाँ पे आप लिखोगे Vs into Is is equal to Vp into Ip. Vs into Is 88 watt it is given. ठीक है. Vp is 11,000. Ip, sorry again. मेरा दिमाग पता नहीं अभी कहाँ चला गया. I don't know. Sometimes it happens. Sorry, primary is given, right? Vp into Ip 88 watt. So Vs is 11,000. Is you can calculate, right? So that was what was getting asked. Now let's do this question. इसमें simple calculation ही करना है. Do it. I hope तुम लोग जल्दी calculate करोगे थोड़ा. ठीक है. We will do 2 more questions from circuit, AC circuit. ठीक है. Then I will end the class. This is a pure calculation. Anyone? वैल्यू निकाल टाइम का वैल्यू निकालना है व्हेन चार्ज एम्पलीट्यूड डिक्रीजेस टू दिस मच. सो Q इज इक्वल टू हाउ मच? Q नॉट e टू द पावर माइनस RT by 12. So you have to calculate time when Q will become Q naught by 2. 0.5 Q naught means Q naught by 2. So Q को आप Q naught by 2 कर दो, Q naught e to the power minus RT by 12. This will get cancelled. So this is 2 का power minus 1 equal to e to the power minus RT by 12. Take ln on the both side. So इस side भी मैं दोनों ही side ln को लेने जा रही हूँ. ln function I'm taking on both sides. So ln here and also ln here. So this will become minus ln2. ठीक है, क्योंकि log के बारे में पढ़ा है, a to the power minus n है, तो इसको हम लिख सकते हैं n log a. ठीक है, so here it is ln का मतलब log का base e है. ठीक है, so this is minus ln2 and you already know ln means base e है and this is this into e minus rt by 12. So in इस केस के लिए फॉर्मूला क्या हो जाता है, दिस विल सिंपली बिकम माइनस RT by 12. व्हाट इज द फॉर्मूला? फॉर्मूला इज दिस कि अगर तुमने लॉग का बेस a लिया है एंड हियर देयर इज a टू द पावर समथिंग, देन दिस होल विल बिकम x. ठीक है, सो हियर लॉग का पावर बेस था एंड देन e टू द पावर समथिंग, सो दैट समथिंग विल बिकम हियर, विल कम हियर. ठीक है, नेगेटिव नेगेटिव कट कर दो. नाउ वैल्यूज आर गिवन, यू सिंपली नीड टू कैलकुलेट इट. ठीक है, आंसर विल बी B. Now let's do this question. Peak current in the circuit. जल्दी से बताओ क्या होगा. Before that, let me tell you one thing. इसकी में मुझे एक चीज तुम लोगों को बताना था. Whenever there is voltage given in your question, ठीक है, whatever voltage is given, that voltage given is always a RMS voltage. So यहाँ भी जो voltage दिया है ना, that is your RMS voltage. It is not peak voltage. ठीक है, so question में कहीं भी voltage is mentioned, that is RMS. Now calculate the peak current. Peak current क्या होगा बताओ. Okay, very good. I got one correct answer. Peak current will be peak voltage by impedance. So peak current को क्या लिखोगे? Peak voltage by impedance. V naught क्या होगा तुम्हारा यहाँ पे? 210 root 2 because this is a RMS voltage and V naught by root 2 is equal to how much? Here 210. So peak voltage is 210 into root 2. Yes, Shreya. Very good. So this is this, right? And this by z. Z का वैल्यू मैंने क्या बोला था? xc minus xl का स्क्वायर प्लस r का स्क्वायर. And here xl is not there, r is not there. So it is basically xc. And xc is 1 by omega c. So this is 1 by omega c. यानी कि 210 root 2 into omega into c. Omega here will be equal to how much? F is given. So f को omega में कैसे convert करते हैं? Omega will become 2 pi f. Omega is equal to what? 2 pi f. So here you will write 210 root 2 into 2 pi into f, that is 50, into capacitance, that is 10 to the power minus 5. You will get the answer. Okay? There is only one question left. We will be doing that tomorrow or next class. Okay? And after that we will revise modern physics and all. Done. कल तो टेस्ट है, तुम लोग टेस्ट सही से देना. After that we will come back to modern physics and everything. We will do lots of questions there. No discussion on concept, क्योंकि that is basically memory based thing. So we will be doing more number of questions. Okay. Thank you everyone. And Puneet, I will get back to your question also. The one you have asked, I have taken the screenshot. I will try to understand what you were trying to ask. Puneet has left the class. Okay. Anyway, chalo. Bye everyone. Take care of yourself.